For section 5.2, we're going to look at operations with polynomials. So we're going to be adding and subtracting and multiplying polynomials in this section. All right, let's look at our first example. I'm adding this polynomial to this polynomial. Now the rules when adding and subtracting is you just put all your like terms together. So when you add or subtract any polynomials, all you do is put like terms together. So as I'm looking up here at my problem, I'm going to put a to my fifth with a to my fifth, a to my third with a to the third, a squared with a squared, constants with constants. And we do want to go in descending order, so we're going to start with the fifths first. 3a to the fifth plus negative 8a to the fifth happens to be negative 5a to the fifth. Now looking at my cubes, I've got negative 9a to the cubed plus 8a cubed, which is negative 1a cubed. 4a squared doesn't have any like term to go with him, so we're going to just bring him down as positive 4a squared by himself. And likewise, positive 2 doesn't have a constant to go with him, so we're going to bring him down just as a positive 2. This would be my final answer, and I'd be finished with this. Now I want to look at a subtracting example. Subtracting is a little different in that you actually need to take this silent negative 1 out here and make sure to distribute it to every term. So you have to do that first. So my actual problem looks like this. I don't change the first one because I didn't multiply anything in. Once I distribute this negative 1 in here, that actually becomes a positive. And I've got negative 3p to the fourth, negative 5p cubed, and a negative 2. Now this becomes an addition problem, and I just put my like terms together. P to the fourth with p to the fourth, that becomes negative 2p to the fourth. P cubed with p cubed, that becomes negative 4p cubed. And constants with constants, and that becomes a positive 3. And that's my final answer. Okay, let's take a minute and review multiplying polynomials. So I've got a monomial times a polynomial here. I've got a monomial times a trinomial. And when this happens, we all know that we distribute in. Now when we distribute in, we've got to follow our monomial rules that we learned last section, which is when you multiply like bases, you add exponents. For example, 5 times negative 4 is negative 20. X squared times x squared becomes x to the fourth. When you're multiplying like bases, you add the exponents. Now let's do the second term. Positive 5 times a positive 3 becomes a positive 15. X squared times x to the 1 becomes x cubed. And then last but not least, positive 5 times negative 2 becomes negative 10, and x squared has nothing to multiply to, so I just carry it down. And that would be my final answer. Now let's look at multiplying a binomial times a binomial or a polynomial times a polynomial. When you multiply a polynomial times a polynomial, you have to use your distributive property. So basically I need to take this 2k, this first term, times everything in the second set of parentheses, and then I've got to go back and take this negative 5m, or this second term, times everything in the second set of parentheses. So the 2k gets multiplied by everything, and then the negative 5m gets multiplied by everything. And that's how you multiply polynomials. So let's start with our 2k. So 2k times 3k is 6k squared. 2k times positive 2m is positive 4km. So 2 times 2 is 4, and then the k and the m get carried. Now I'm not done. I've got to go back and I've got to take everything times the negative 5m. So negative 5m times 3k is negative 15km. Negative 5m times positive 2m is negative 10m squared. Now usually what happens is you have like terms in the middle here that you need to put together. So we're going to switch gears. Now we're adding and subtracting, and the rule with adding and subtracting is just put like terms together. So 4 minus 15 is negative 11, and then we just carry down the km. And then, of course, that negative 10m squared. That would be your answer. All right, last but not least, we have a binomial squared here. Now I want to show you the wrong way to do this first, so let me make it clear that this is the incorrect way to do this. The biggest mistake I see is I will see students try to distribute that squared in, like we learned last section. The reason this is wrong is because of this minus sign. The only time that it's okay to distribute an exponent into a set of parentheses is if there's no plus or minus. In other words, it only works if it's a monomial, not a polynomial. So that being said, how the heck do we do this? Well, the way that you do this, p minus 5 squared is, in essence, p minus 5 times p minus 5. Remember, anything squared is itself times itself. So what this ends up being is just like our last problem where we use our distributive property. So we take the first p times both of the terms. So p times p is p squared. P times negative 5 is negative 5p. And then we take the second term, this negative 5, and we multiply him times everything in the second set of parentheses. So negative 5 times p is negative 5p, and negative 5 times negative 5 is positive 25. Now, just like happened in our last problem, we've got some like terms in the middle here that we've got to put together. And remember, for like terms, you just add and subtract those coefficients, giving us a negative 10p plus 25 to finish out this problem. Very different note from the example, from the answer, we were going to get over here.